Hi, I am Alan C. Smith, CLA, CLED, LabVIEW champion, stuff. I am really glad to be here. I'm really excited about this event. If you're wondering about the zebra, my daughter sends me with a plushie when I travel overseas, and I take pictures of it in cool places, and she thinks that's awesome. This is a cool place. Hopefully somebody will take a picture of the zebra and I can share it with my daughter. She's 11. I'm enjoying the fact that she's 11. Moving on, as I said, I'm Alan C. Smith. I have been writing LabVIEW applications for, yes, I guess I can say this, a quarter century. Half my life at this point. I turned 50 on the 1st, which is pretty cool. I have been an alliance partner. I have worked for alliance partners. I am once again an alliance partner, offering services as a consulting architect. And I have been, I did a stint for 6 years in systems engineering at National Instruments, where I got to write the Actor Framework project provider. Total side project, not connected to my day job, but I had a lot of fun doing it, and I actually got to have stuff put into LabVIEW, which is really, really neat. And that's what I'm here to talk about today. Kind of segues nicely off of some of the stuff we've heard this morning. Richard was saying this morning that one of the things you get with a framework is tools. And I argued that if you don't deliver tools with your framework, you haven't delivered much of a framework. That's from personal painful experience on my part.
Alan, sorry, just one question. What's the name of your job site?
I'm not sure I want to share that in a public forum, if that's all right. Ask me offline, I'll be happy to tell you. But I don't want to just broadcast. Just put big M. It starts with an M. We'll leave it at that. Okay, so that's a bit about me. I'm talking about the project provider. What am I hoping you get out of this? I only have 45 minutes. I can't turn you into a scripting ninja. You should talk to Darren about that. It takes a little while, but he can hook you up. What I hope to do is show you a couple of cool things. So if you're doing any scripting on your own, maybe I can save you a few hours. But also, the neat thing about Actor Framework stuff is that it's almost all open to you. There's no secret sauce, or very little secret sauce. So I'm hoping that you can take a look at this. I can show you how it's laid out, and then you can go do research on your own and find out, well, gee, the project provider does this cool thing. Can I do that? Yes, yes, you can, and you can go look up how to do it. So hopefully when you're done, you'll have a sense of how it's put together. You'll have learned a couple of tricks on your own, and your life will be better. That's my goal, is to make your life better. Who here has done VA scripting? Outstanding, not surprising. Who here has written a project provider? Also good, more than I would have expected. Who here likes writing project providers? I have self-harm tendencies. What can I say? Okay, so with that in mind, what I'm not going to talk about for lack of time is the basics of project providers or the basics of scripting. There are excellent materials available currently. Yes, go ahead and take a picture of this. The NI forum content is where you get started with all the stuff you need to get going, all the documentation, some examples. David Lalachetta has an excellent video on project providers that was actually at my home user group, the LabVIEW Architects Forum. He presented that, and so we're sharing that. So go there for project providers to get started. When you want to get started with VI scripting, again, go to the NI forums. Lots of good stuff there. I'm still trying to hunt up some stuff that I know is out there that isn't on the forums yet. Darren Nattinger has an excellent presentation. That was last year. This NI week, Darren did a presentation. He shared that up. So all this information is out there. Go watch it, come back, I'll wait. No, really, I can't do that. That's where you should go for your basics. What I am going to cover is this specific project provider in a little bit of detail. So I will talk about menu population and launching an operation, which is what the provider does for you. And then I will talk about building messages. How many people are familiar with Actor Framework to some extent? Okay, so you understand that the idea is we send message objects around, and the project provider tools are what make those message objects. Took about 4 years to write. Again, this was a side project, so I was doing this in addition to helping customers understand how to use LabVIEW. Took about 4 years, starting right after Actor Framework shipped, or right after I came to NI, and then we delivered it in 2015. Do need to give the obligatory words of warning about project providers. The project provider framework is poorly written and poorly documented. The fellow who wrote that and then left NI and says nasty things about us now, apparently. But he left us with kind of a mess. David Latocetta and his team did an awesome, awesome job of going through and documenting what we know about how the project provider framework functions. However, there are odd behaviors. As I've discovered to my personal pain, there are odd interactions sometimes between your provider and other providers, which shouldn't be, but are. There are undocumented features. Hey, what's this setting going into this API call? No bloody idea. Nobody knows. So the result of this is that while NI uses the provider framework and we use stuff built in it, so the source code control provider, the app builder provider, those are all stuff that we use on a daily basis. NI uses them. When they run into a problem, they can do the deep dive. But they share it with us as is. If you're writing providers, you proceed at your own risk because here there be dragons. But as Chesterton told us, dragons can be beaten, and when they're beaten, they're often sitting on big hoards of treasure. So it's worth it sometimes to go through the pain and understand them. So what does provider do? Providers provide the way. They are a way of connecting some scripting code or other activities to an item in your project so you can operate on them. Okay? So they give us some stuff to make that happen. The provider will validate that you're looking at the kind of project item, like a VI or a folder, that you think you're looking at. It'll validate that item. It will give you information about that item that you can pass into your scripting code. And then it will invoke the scripting code so you can perform whatever operations there are, like, say, make a message for an actor method. Okay. Speaking of, I will outline the problem just a little bit. Actor Framework provides 3 message types. Our standard message between actor A and actor B, which is just a little class, right? And that little class has some data, and that there's a send VI that will bundle that data into the object and put the object onto an enqueuer and send it off to the receiver, where the receiver will invoke a do. Okay? If you're not familiar with Actor Framework, don't worry too much about it. Just understand that I have to make a small class with a couple of VIs in it. Actually, I have to make another type. This is an abstract message class. Also has data, also has a send, but the send now takes a class type as input. Does not make a do, makes something called a read attributes. My third message type is a child of that abstract, so now I have an inheritance relationship that is not my standard relationship. There's no data because it inherits from something with all the data I need, therefore no send, but it does have a do. So my point in bringing this up is not to give you a crash course in Actor Framework, but to show you that I really have essentially very similar types of operations that I have to do, but with minor variations depending on the specific thing I'm trying to accomplish. So kind of a matrix of stuff that I'm trying to do. How does this actually get turned into those handy right-click menus that we all know and love so much? Well, I start with, at a base, I have a message maker library, which started off as 14 VIs, and now it's 44. And this is this is my API into scripting. So it's just a bunch of, it's VIs that encapsulate specific scripting calls to do all of these specific tasks out of that matrix that I just showed you. And that's, like I said, it took about 44 VIs to pull that off when all was said and done. But I need to partition that out to specific code paths for my specific types of message, which of course are similar. So on top of this message maker library, there are a set of scripters. These are template method classes. So there's a template that we follow, which I will show you. Each of the scripters for the 3 message types and then the rescripting operations fill in methods, override methods of those basic types. Template method stuff. I do have some instances where I have operations that are shared between 2 scripters, but are essentially the same or very, very similar. And those I implement with some strategy pattern classes that are just little classes that, hey, I need to do, I need to build a specific thing right here. Well, here's the strategy to do it. And so I have this class set sitting on top of my message library. Now I have to make this all go, and I need some stuff. I need some information. I need to know things like the method that I'm targeting my message to. I need to know the actor that it belongs to. I need to have, the target my computer or a Rio that I'm looking at. These sorts of things I have to give to my scripters so they can do their jobs. Getting that information is the role of my project providers. And I say project providers, plural, because there are 4. Why 4? I'm only doing one thing, right? I'm making message classes. Well, here's a fun fact about project providers. At least the secondary providers, the ones that actually operate on things, target specific things. There's a list. That list is in the documentation that's available on the forums. So things like a VI, I target a VI, or I target a folder, or I target a class, okay? Or I target a target. And these all have these unique IDs, and the providers are connected to those IDs. Now, in theory, I can actually write a provider that will target multiple supported types. In practice, this is where the provider gets a little weird because I had some trouble getting it to work right. Also, it conceptually made a certain amount of sense because I actually do target 4 separate things for 4 different types of operations. So add actor, the provider that makes a new actor in the system, it targets targets or folders. Or not folders, I'm sorry, it targets or libraries. I'm not going to talk much about it today because it doesn't do anything interesting from a scripting perspective, just a little bit of copy and class, which I'll show you how to do later. But it's there, and it acts, like I said, it acts on a target. The message maker provider acts on methods, acts on VIs, specifically methods of an actor class. That's where we can create actor messages for a standard message or one of our concrete child messages because that targets a specific method. The actor message maker targets actors, a class that is an actor. And that's how I can make multiple, all the messages for an actor, or I can make an abstract a message to send to caller, excuse me. And then finally the message rescriptor, which targets message classes, okay, and lets you rescript those. Sadly, I will not have time today to talk about how the rescripting is done. I don't have the time for it, but you can talk to me offline. It's not that hard. Okay, so all that said and done, I've got these 4 providers. They all essentially have to do the kind of same thing. They have to get me that information I need. And they do that through a project provider API, which is in LabVIEW. It's on your hard disks already. And it's a bunch of VIs that act on this blue wire. The blue wire is the NI nickname for it. The blue wire is just this U64, which is a type of reference. It's not a VI server reference. It's just a different reference system. And then the API objects act on that. And they give us the stuff we care about. Things like a ref num to the item. And that is a proper VI scripting ref num. So EAS, that gives us everything we need, right? Or the target that we're operating on, or the project path. And then, of course, I know the provider that I've invoked, and that tells me certain things as well. I know if it's the, if I'm invoking add actor, I know I'm adding an actor, for example. So that constrains me. So we have there's things we need, there's things we have that'll get us what we need. There's also something very important that we should not forget. You might have noticed that the API VIs for the project provider all have this MXLV prefix in front of them. That is a nod to the notion that project providers run in their own application instance. How many of you are familiar with LabVIEW's multiple application instances? How many of you have totally screwed yourself up with application instances? Okay, yes, you do really need to hold on to the app instance of the project that you're working in. It's really pretty critical, because if you don't, you'll run into what I've been calling the outside context problem, to borrow from Ian Banks. And I borrowed this quote because this is exactly how I felt when I started working with application instances, in that my development hit like a sentence hitting a full stop. I was done. Things, if you don't get the app instances right, things that work when you're just doing test development, you'll drop it in the provider and they don't work. Or worse, they do something really weird that you completely didn't expect. If you encounter that in your own work, that is very likely that you don't have the application instance correct. So do pay attention to that, hold on to that. All right, great. So our users go to right-click on something, we activate a project provider. What actually happens? Okay, so user right-clicks on an object. Your project provider kicks in. Actually, they all kick in. The framework will go and look at all of the registered project providers, and we'll find out which ones are connected to which items, and if you've selected an item of the right type, that project provider or multiple project providers will activate. That's where we get to go populate our menus. What happens is this VI called item on pop-up menu. It's a VI that you as a project provider developer provide. It's one the framework expects to find. That gets called, it gets invoked. What do we do there? Okay, remember here, we're targeting a VI, but we need a specific VI. We need a public method of an actor class. Okay, so we got to do some validation ourselves, and that's what we do. So we go off and we grab, our item reference, and then we've got, in this case, it's just a single VI, where I go and I check to see if it's all of those things, and if it is, I'll pass out, in this case, a true, and I will go put stuff in a menu. Woo, there's a table right there. I'll go put stuff in a menu, and then the user can select that. Now, you need to be timely on this, okay? If you right-click, if you don't do this right, and you right-click on this, and it takes more than maybe 100 milliseconds, your users are going to wonder what's going on. If it takes a lot of time, they're going to think that they've hung LabVIEW somehow. And it's entirely possible, if you don't do your jobs right, that yes, indeed, they have hung LabVIEW. And you have to start over again, which is a drag. So you have to be timely here. Now, the good news is that VI scripting calls are for the most part very timely. So I'm peeking inside that item validation that item validation is called isActorPublic method. I'm taking a peek in there. For example, to get the VI's path, or to get its library access scope, which I need to, is this a public VI that I can act on? That's very quick. It's so fast you don't need to worry about it. However, I have to go determine, is this a part of an actor? Which means I have to load a hierarchy. If you do that wrong, that's going to take a while, especially if it's deep hierarchy. The good news is that inside that inherits from actor, I'm calling a little VI called read class ancestry without loading, which is your personal friend here, because that will tell you it works on a class, it works on a method of a class, and it will give you the entire hierarchy, inheritance tree, of that specific class. And then I can go look at the one in the top, and I can say, oh yes, it's actor.lv class, so we must be part of an actor. That without loading part is critical. So that's a really handy VI that you should stick in your back pocket. Another way that you can save time, and I only do this once in the project provider, but it's a handy tool and you should know about it, is you can put a tag on a project item. And I believe it's just about any project item. Is that right, Darren? Yeah, pretty much any project item you can put a tag on, and a tag can be anything. So the way I used it is, there is PPL support for in Actor Framework. You can make an AFPPL and point the tools at it, and you're good to go. And I use tags for that. I'll tag the target, and I'll say, hey, you have a PPL associated with you, and here's its path. And that saves a lot of time, a lot of going and looking stuff up. So I encourage you to use that. Both of these things leads me to my actually next really serious tip. Both that user tags API, because there is an API for it, and read class ancestry without loading are a part of hidden gems in vi.lib, and we have Darren again to thank for that. That is, there's no code, when you download that VI package, there's no code that comes with it. It's just a set of palettes. But they point you to all of these really nifty, handy little VIs that people over the years have written and put in VI Lib to solve NI's problems that Darren thought you should know about. And I was really tickled that he put Save All This library in there, because I wrote that for the project provider, but that's a really handy thing to have. So it's in there as well. Another fun bit that's in there is icon management, where you can go programmatically adjust the icons of your VIs, which we use in the message maker to make classes that actually look like something on a block diagram. My former colleague, Karsten Van Zwal, in the Netherlands, did the work of figuring out how to do that for our classes. Saved me a bunch of time. That got rolled into the project provider. Yay, Karsten. Okay, so that's a little bit on validation. Got to be timely. Got to look at some of these tricks to make sure that you're not taking too much time. Once you've clicked on that menu item, though, right, So you found out that you've got the right stuff, you put stuff in the menu, user selects that, and that kicks off a bunch of code, hopefully. Now, that is actually really easy. That invokes something called item on command. Again, you provide that, but item on command can be this simple. Okay? Just like every other instance of menu manipulation in LabVIEW, you get a string. In this case, the guy called it command ID because he had to be different. And you just do useful things with that string, like wire to a case structure and invoke a VI. Which leads me to building messages. Because now we're out of the project provider and we're into message building. It's all part of the project provider, but we're out of the stuff that's specifically project provider API. Got a set of tasks we've got to do. You'll be not surprised to learn that each of those tasks has a VI in my template class associated with it. So prototyping is just where we go and we scrape a VI for front panel controls, basically. It's a target VI typically. What data should be in our message class. Then we go and we copy the class from a template. Then we set attributes of the message. Then we have to modify a send VI, and then modify a do VI, and that's message making. So I will go through these one by one just to give you an idea what's in there. Prototyping, scraping controls from a VI. This is an instance where I did actually use a strategy class instead of an override. Because I'm doing, in the case of abstract messages, I have a couple of different things that I'm doing. There's a target method prototyper, which goes and looks at the VI the message targets. Reference method prototyper, which is I'm going to go look at some unassociated VI that has the right connector pane that I care about. Or user defined, where you get a dialog box you get to pick. The target and reference method prototypers both invoke copy member data from target. Okay, which is again, so we drilled down, from my scripter to my prototyper and down into the message maker library. Copy member data straightforward. I grab my connector pane off my VI. I grab all the controls off that connector pane, and I grab those wiring rules. The wiring rules are things like this connection is required or recommended or optional or so on and so forth. Then I do a little validation. Got to make sure I've got the right stuff. If there's no control at that point in the con pane, I don't care. If it's an indicator, I don't care. If it is the target actor's class in the upper left-hand corner, I assume it's the actor class, and I don't care, I ignore it. Same with an error cluster in the lower left. So yes, it is possible if you make a non-standard VI for your actor that you can not get good message creation out of it. Something to keep in mind. But I do that winnowing down, and now I just have this list, and it's just an array of references to a G object. In this case, a control of a particular type. Okay. But what about user-defined, right? I said I'm just scraping a VI, but I'm giving you a front panel that you can fill in. Well, that uses the user-defined prototype, which just invokes add attributes to message. Add attributes to message is this VI, it's this front panel to it. This VI pops up, you get to go put controls down that you want down on that editable space, and then you click create message. Let me say that again, because it's really cool. This is an editable space on your runtime front panel. That's very cool. How do we do that? I'm glad you asked. Excuse me. All I did was make a scratch VI. Okay? That's new VI off in the corner up there. Made a scratch VI, and then we insert it into the subpanel. And then when the user clicked the button, we pulled out the subpanel and pulled all the controls off of it. Now, I used to think, those of you taking pictures should take note of this, when I wrote this initially, I used to think that I needed that edit mode, that making it VI editable was the way to, or was part of solving the problem. Turns out it's not. I'm showing you that so that you won't go down that road yourself. The way you have to do it is some special private settings of the subpanel control that we non-NI people don't have access to, sadly. However, so you have to change a setting on the subpanel itself. I I was not given permission to share, but I was told that I can give you a VI, and I will make this available, that has, that has all 3 types of subpanel on them, all with that configuration established for you. Grab this VI, take the version you want and put it on your own VI, and you're set, you're golden. The setting will go with the control. You can also just open up that add attributes and grab this guy. I think you can do it off of the add attributes. I don't think that one's password protected. So I'll make this available. Okay, so we've got our attributes now, and it's just an array of cluster of control references, right? So now let's go create a class. And we do that by copying from template. Literally every person who tells you about scripting and to do scripting will tell you, as I am, to start with a template. Okay? Here are my templates. Every node, every wire, every connection that you have to script costs you time. So every node, every wire, every connection that you can put on a block diagram to start with before you do any scripting will save you hours of writing and debugging. Not kidding, use a template. In the case of classes, where I'm using an entire class as a template, a couple of extra things to keep in mind. These guys are not in a library. They also don't inherit from the basic message class yet. Why is that? This is literally the simplest I can make it for copying and manipulating. Because if you grab one of these guys and it was in a library or was inheriting from something, you would automatically pull that stuff in. We don't necessarily want that. So keep them clean, keep them simple. You can change the inheritance later, as I will show you. So use a template. This is also a case where paying very close attention to your references, your application instances, is critically important. Because the copying a class is simple, right? I just open up the class, and then I save a copy of it, right? It's simple, you know, I mean, it doesn't get any easier than that in scripting. However, this LabVIEW class open can be a problem. You'll notice that I'm using the default application, not my app inst, but the default application. So if you were looking in DETT, you would have your project, and then you would have main application instance. I'm doing it there. Why? Classes don't exit memory once they've been loaded. Okay? That can be a real problem if I've pulled my template in to my project. My template's in my project until I close my project. That's going to cause problems later. So we make the copy in this separate application instance that's not connected to my project. Then I close that instance. And guess what? When you close the instance of LabVIEW, the class goes out of memory. Yay. So really important. This is one of those instances where it's really critical to pay attention to that app inst. Once I've copied it, now I have a separate thing that I do want in my project, and I can go ahead and open it up using the project's app instance. And then I can go and change its parent class, and I'm good to go. All right, so that's creating a new class. Pretty straightforward. Add member data. I'm taking those control references, and I'm adding those controls to class private attributes. And I can't show you how I did that because it's a little bit, just about that much NI secret sauce. A couple of private methods in there that I'm not permitted to share. You can do it without using the special sauce, but that's not my provider. It's not that hard. And again, this is another instance of I can't give you the stuff under the hood, but the stuff over the hood is actually just fine. Add member data to private data control will do everything you need to do. Takes an app that's in, class path in, your controls, run that, and you're good, and you're done. Now, I have asked my contacts at NI, Darren, if there's a way, because right now if you go and you grab this and you pull it in, you're going to pull in all 44 message maker VIs into your project. You don't want that. I've asked to get a copy of this exported out of the library, so possibly it can become another hidden gem or something similar. I don't know if that's going to happen or not. I've made the request. You can also just copy it yourself if you need to.
So I was going to say that some of the stuff that you're saying that is super secret and blah, 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 something else, in the presentation that I gave at CLA Summit and the YouTube videos out on tell them what the token is when I show it on the Google search,
Okay, yeah.
on the video, so.
Yeah, well, I mean, you can find this primarily. It's kind of an open secret, but as a former NI employee, I am actually still bound by some stuff.
Yeah,
So.
I'm just saying, just send them there and they can find it on Google.
If anybody wants to know how to do this without the secret sauce, I figured that out too. So.
Yeah, it can be done. I didn't want to go and show you a different way than what I'm doing in the provider, especially when you have really I've done it for you. Just take this VI and go, and you're good. I looked at it. It's awesome by itself. All right, moving on because my clock is ticking. Okay, make send. So now we have a class, and we've copied our class over, and we've populated it with its attributes. Now we can go modify the send VI. This is another case of starting from a template and modifying the template. And I need to do two things. Well, I do several things, but there are two broad categories. I need to modify the front panel, and I need to modify the block diagram. And we'll start with the front panel. I need to add new controls to front panel, and then I need to connect them to the connector pane. All right, how do I do that? Well, adding controls to the front panel are pretty straightforward. You use this control move guy, and I take all of my control references that I've had, and I add them in there, with the owner being the front panel. So I get the VI's front panel. Front panels have panes. You've got to make sure you grab the right one. In the case of my template, it's pane number 0, and that becomes the owner. This, by the way, is also used to add those attributes to the class. It's a part of it. Any container, any front panel or frame of a case structure or a cluster is going to use this. Something that took me, a little bit of time, actually I think it was a same time message to Darren, was, well, what's the deal with control move? Shouldn't there be a control add? And there isn't. That's actually what the flag duplicate is about, differentiation between moving and an adding. So hopefully I just saved you 30 seconds. It's control move, not control add. Now I've added them to the front panel, got to add them to the connector pane. How do I do that? So again, I get the connector pane reference. I grab all the controls off the connector pane and I go and I inspect them. Now I alluded to this earlier, but you actually get a control reference for every terminal on the connector pane. Even if it's not connected, you get not a number. So in the case of our standard 4224 connector pane, you get 12 references back. Once I have those, I can inspect those. The ones I'm interested in are the ones that have no connection, in this case. And those are the ones that I can assign controls to. And that's that con pane assign control to terminal, which takes the control that I want to assign and that terminal index, the index of the terminal in question. Similar pattern for the set wire rule. A little bit more about those terminal indexes, or terminal indices. How can you find out what they are? Because in my case, I'm just barfing a bunch out. You might care about a specific terminal index. You've all seen, does everybody know what the numbers and brackets are? Actually, you probably know by now. Yeah, those are the terminal indices for the connections on that particular con pane. There's not particular rhyme or reason to how those numbers get filled in. So your best bet is to go to this connector pane pattern reference.vi, which is a LabVIEW example. And that has every con pane that you can have, including the ones we never ever use because they're ridiculously complex. And it will give you the numbers for all those terminal indices. So that's a reference for you guys. Okay, done with the front panel and the con pane. Now I've got to go to the block diagram. And what I have to do here is the template has a placeholder message object. It's either just a cube on the block diagram or it's a control. I need to replace that with the correct, the one for the message that I just created, or I'm creating right now. And then I have to connect all my new controls on my front panel to that bundler. So how do I do that? I got to find those guys. I find them through the use of labels. I give my objects of interest on a block diagram or front panel a unique label name. And then I use tref find object by label, which is another hidden gem. So that's a really good VI. That will go, and it's pretty fast too. It will go find your object on your front panel or block diagram by label, give you the reference back, and you do what you need to do. If you're swapping something out, it's gobject replace. If it's something like a bundler, you can say, I'm going to resize it and add chunks. So every one of those little terminals on a bundler is called a chunk. I don't know why, but it is. Kind of a neat name. And you're good. Once I've made the bundler the right size, now I'm going to go and connect up my controls to the bundler. Here's another fun fact. You connect to objects using terminals. I mean, just like when we're wiring, right? You don't connect to objects, you connect to terminals. Control references have a terminal, so you control, give me the terminal. Bundler has an array of terminals, and you get those terminals and you wire them together using, terminal wire, connect a wire to another wire, where wire source is the other wire. Fun fact, tunnels, if you're talking about a case structure or a while loop or a for loop, they don't have terminals, they have tunnels. And tunnels have an outside terminal and one or more inside terminals. So you have to connect to, you have to find the tunnel on the frame and then connect to it. You can use, if you just get that first wire going across there, you can use the reference to the structure as the wire source, and that will make a tunnel for you. I don't think you can just create a tunnel, can you? This is how you make a tunnel. Okay, so you'll connect a wire to the structure, then you got to find the tunnel you just connected, you got to find its other terminal, and then you can connect on the inside. Kind of a drag, but there it is. That's make sender. Make receiver is not substantially different. Different target VI, but the same kinds of operations. I need to, I'm doing stuff on the, in this case, just the block diagram. This is an instance where I do have, my scripters do each of my 3 scripters provides an override VI, and then they invoke slightly different things in the messaging library. Like I said, I'm doing the same stuff, right? I've got to change out a control. I've got to change out a couple of VIs maybe. I have to wire some stuff together. I just showed you how to do that, so we won't go through that again. But I will point out something. I will talk a little bit about the purpose of this case structure here, which is not something that shows up in your final message class. Why is it there? Well, it's there for, it's kind of a fundamental reality when you're doing scripting, is that we're not so much writing automation software, is that we are automating stuff we would do by hand. Sometimes it's really useful to think of it that way. And this is a kind of a by hand trick. If I had to drop the target method onto the VI that's invoked by do, if I had to drop that on a block diagram, figure out its connector pane and wire it up, that would be many, 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 many block diagrams full of code. When in fact there are, for any assumed arrangements of the target method, there are really only about, there's 6 possible variations of wiring that cover all of those variants. Whether I have, whether the class in, class out are present, whether error in and out are present, I can resolve it down to 6 different possibilities. So we're going to go with the theory that it's easier to remove code from a template than to add it. And so here's what we do. We go find an instance of dummy method. We replace it with the VI that we care about. Then we go look to see if any wires are broken. Okay? So here we go. This is removing template code. This is an eye chart. I will zoom in. I've made that substitution, right? I go find the owner of my VI, which is this right here. Well, the owner is a diagram. It's not the block diagram, it turns out. It is one diagram associated with one frame of the case structure. So a little small portion of the block diagram. Hey, do I have any broken wires? If I have broken wires, I know I have an invalid wiring case, and I go and I do the next one. So I'll go find the next instance of dummy, replace it, and see if I have broken wires. Eventually, either the first time or the 6th, or somewhere in the middle, I will get to a diagram that is not broken. That is valid, and I can proceed. Okay? So what do? Hey, that diagram, give me your owner, the case structure you belong to. Give me all the frames of the case structure so I can find out which one I care about, which one's actually not broken. Make that frame visible, and then remove the case structure. When you remove the case structure, the visible frame just merges into your block diagram, which is how we do that. So I have about 5 minutes left, and that's it. That's really kind of how a message gets made. There's some additional stuff about saving. You'll save all this library, gets invoked to make sure everything's clean, that kind of stuff. That's really kind of the meat of it. So just quick review, and then I might have a time for a question or two, or however many you want before lunch. Keep your application instances straight, please. You will thank yourself for that work. Use templates wherever you can, and when you use them, remember that it is better to delete if you don't need it than to add it if you do. Hidden Gems in VI Lab is your friend. Go download that, right now. It's really awesome. And then finally, I enjoyed writing Project Writer. I'd be happy to write another one. I think there's a lot of value in that if you're delivering a framework, and they are voodoo. Okay, weird stuff happens in there that you don't understand what's going on, and you kind of have to be prepared to go on the ride. But if you plow through it, you can do some really cool stuff, like change LabVIEW, which is neat. So that's all I have. If you want to follow up with me after the conference, that's where you can find me. Some version of this presentation will wind up on my brand new Vimeo channel, Ready on the Wire, which is cool LabVIEW stuff. And that's all I have. So do I have any questions? Clearly you all want lunch. Oh, question.
I don't normally need a microphone. How long between thinking of the need to put a provider in place and actually getting on with it did you take? Because there's always that point between, I know I need the tool, I just need to get on with it now, and then you actually do the tool.
I knew, so I was using Active Framework before it was released. And on my very first Active Framework, about my 23rd message, I said, dear God, I have to be able to script this. And then I got hired to go to NI. And how long after I got to NI did it take me to reach out to you? Like 3 months? It's not long at all, because it's like, oh, I get to do side projects? So I started that right away. So that one I knew I needed it. I knew it was pretty important. We were in active development of Active Framework, and so I pushed on that. The gap between that and writing the full provider, because the original message maker was just a tool. The full provider came much later. I wanted to do a provider, but was told by several people, Darren among them, not to, because here there be dragons. Then David Lanos edited his work, and I decided to push on that. It took probably 2 years to get it all done. I mean, I actually had a version that I was using privately for a while. I'm not sure. I think it was a few months probably each time, and then I would find new stuff I had to do, and I would do it. So probably a few months lag. But again, I was in a role where I was expected to do stuff like that. If I wasn't solving customer problems, I was supposed to be doing useful things. So I don't know. I do know that I've had a tool that I've been wanting to write since the last CLA summit that I'm actually working on with Sam Taggart, that it's taken us a year. It took us it probably took me 9 months. No, it took me until Madrid to get him on board because I just didn't have the time. So that's always the thing, right? Here's the code that's billable to customers. Here's a tool I want to write. Guess which one wins? Oh, gee, I like to eat. So it's probably partially driven by pain. Okay, cool.